All right. Good morning, everybody. This is exciting. I recognize a bunch of you from the list from other workshops. So welcome back and welcome to all the newer people. Today should be fun and fairly hands-on. You'll get to make some cool things. Um, However, I'm not going to show you how to make. So what we're going to be covering today is how to make documents, websites, and dashboards. But we're not going to make like super fancy websites and dashboards because that's up to you. You all have specific department needs, specific research needs, and purposes for making these things. So we're going to make like super basic kind of ugly websites and dashboards just to show how it all works. But then after this, it's up to you to go make pretty things. And if you've been to previous sessions, you know how to make pretty things. We talked about graphic design a couple sessions ago. There's a recording of that, I think. Um, and you can learn some basic principles of graphic design to make beautiful looking websites and documents and stuff. So today's more of just the mechanics of how to get all of these things connected and working, and it should be fun. So let me go ahead and share my screen. If you haven't yet, um, go ahead while I'm getting all of this ready. Go to this website in the chat here, rstudio.cloud. If you don't have an account there, go ahead and make an account. If you do have an account, then just wait, and I will give you a link for an RStudio Cloud workspace that you can work in. You won't have to install anything today because everything is going to be run in the cloud like this, which is convenient. But you can also download RStudio in R and follow along that way too. It's just that all the files that we'll be working with are in these different cloud projects that you'll get access to in just a minute. So go ahead and do that, and let me share my screen and we can get started here. So, as you noticed in the title for today's workshop, we're going to be talking about how to make documents, websites, and dashboards with R and with a special type of markup language called Markdown. And we'll talk about that in a minute and what that means. But with the skills that you'll learn today, you'll be able to make all sorts of really cool, exciting documents that are dynamic, that are accessible, that help with communication. And most importantly, as we'll talk about in a little bit, it's all reproducible so that future you 6 months from now can rerun an analysis and get the same results. Other people can rerun the same analysis on their computer and get the same results. And everything is transparent and open, and you won't accidentally cause European recessions. We'll see an example of somebody accidentally doing that in Greece in just a bit here. So hopefully this will prevent future issues. But before we get started, I want to know why you all signed up for this thing. Why do you want to make websites and dashboards and focus on this type of communication? So go ahead and in the chat in the next minute or so, write or put in the chat why you are here, what you're hoping to do with this knowledge, where it fits in your work, in your research. So go ahead and do that, and I will watch the chat here. All right, cool. I'm seeing some interesting responses here. Lots focused on communication and disseminating information, um, helping with data visualization. These are all fantastic. This is what I teach. I teach a course here at the Andrew Young School on data visualization and on telling stories with data and science communication. So this is all fantastic. Todd in the chat here says, as an alternative to LaTeX or LaTeX. So if you notice in the chat, that weird capitalization there, the LATEX. That is a scientific typesetting program. You've probably seen LaTeX PDFs, LaTeX made PDFs. It looks all fancy and looks super official. It is like this ancient language that was written in like the 1970s, ancient. Sorry, people born in the 1970s or before. But it really hasn't been updated since then, and it is like awful to work with and miserable. The stuff that you create in LaTeX looks cool, but it's miserable to work with. And one thing that's super nice about the stuff I'm showing you here is you don't have to write in LaTeX in order to make fancy LaTeX documents. And you can write in kind of a general type of language called Markdown, and then that will go into LaTeX and into HTML and into Word and into PowerPoint and into whatever you want, all magically and automatically. And also, like, notice how I'm not saying latex. That's because the guy who invented it wanted to be super nerdy and decided that the X should be pronounced like H in German, like Bach. So technically, you're supposed to call it latex, but that's like weird. So nobody actually, some people do if you want to be like a super nerd. But most people call it latex or latex. It's weird. So don't worry about that so much. We will get into that in a bit. So what we're going to do today is briefly at the beginning talk about this idea of Markdown and universal writing. This has less to do with making dashboards and making websites, but it does provide the foundation for making those things. Because if you've ever worked with websites, you know that you have to like type HTML code in order to make websites work. The nice thing about Markdown, which is the special language that I'm going to be showing you, is you don't have to write any HTML either. You don't need to do any HTML tags. You don't need to do any fancy editing. You can just write text with kind of some basic formatting characters, and the rest is just kind of, it magically takes care of itself. And so that's this idea of universal writing that I'm talking about. You write in one document in one type of syntax, and then that can convert to HTML or to LaTeX if you want, or to Word, or to whatever format you want, and you don't have to write in multiple formats. And so then, once you understand kind of the basics of Markdown, we'll then talk about something called R Markdown, which lets you essentially mix our output, like graphics and tables and analysis and numbers, all with regular text. And so you can have a document where you just have text, you're typing like, here are my findings, and then you show your findings in the document. And the really cool thing about this is if your data ever changes, you just have to click on a button and it will recreate the document with the new data. You can even make templates so that if you have multiple schools in your district, you can say, make a report for school number 1. And then you click on a button and it generates the report for school number 1 with all of their data. And then you say, I want a report for school number 2. You change one line of code, click on a button, and you have a report for school number 2, and so on. And you can generate as many reports as you want using the same text. It just changes changes the data that feeds into the document, and it's like super magical. Then, with that knowledge about Markdown and R Markdown, I'll show you how you can create whole websites using R Markdown with no HTML. You don't need to actually like do any hand coding of anything, which is magical. And then finally, you can make whole dashboards that are interactive. Again, with no HTML code, it's all just based on Markdown and a couple R packages that piece everything together to make it really accessible and easy to use. So that's our plan for today. Those things, talk about Markdown, R Markdown, websites, and then dashboards. So I keep mentioning this thing called Markdown. It's essentially just one syntax that you can use that lets you create a ton of different things. The syntax is fairly easy. For instance, if you want to make something italics or italicized, you put asterisks around it, and then that would convert into italicized text in Word or in a PDF or in HTML, and it handles whatever needs to happen. So if you want it to be italicized in HTML, it'll convert those asterisks into whatever HTML tags need to happen for that to happen. So for instance, this is one of the papers I wrote a couple years ago. It's one Markdown document, but I can have it go to PDF, which is this one here. I can have it go to Word, and I can have it go to HTML, all with just like one button click, and it makes all three types of documents. And so I can have an HTML file to put on a website, I can have a PDF to print out that looks nice, and I can have a Word file that people can put comments on and do Word stuff with. But all three of these things came from a single file. Website wise, here is an example website here for an analysis that I did for a paper. It has like this navigation bar, it has this table of contents thing. I didn't have to touch any of that stuff. It was just automatically generated. The only stuff I really typed was the code here for making the analysis with these headings and the pictures. And none of that is HTML. It's just Markdown and R code to make the pictures. You can also make dashboards. This is a dashboard here with just 5 different sections, these 4 numbers at the top and one big chart here. And that's all just through Markdown. Let me show a couple examples to see, so you can see what this looks like more dynamically. So this Who Cares About Crackdown's website, let's go here. Yeah, so what I end up doing for all of my research projects, and you can do this too, because it's fairly easy once you get the hang of this, I have a standalone website for each of my projects that acts kind of as the analysis notebook and a place where you can get the manuscript and the actual paper. So let me put in the chat, I'll put this link here so you can kind of poke around and explore a bit. You can see that like there's the abstract here. If you click on the experiment button, this was a survey experiment. We actually have the full text of the survey experiment here so people can see what we asked and what happened. If you click on the data tab, it shows how we cleaned the data and processed the data. That's all the code there. If you click on tables, it shows all of the tables that we used in the paper. And it's just kind of a cool little way of showing everything we did transparently. If the data ever changes, which hopefully it doesn't because we collected this data like a couple years ago, it'll all update here automatically. And then finally, you can click on the manuscript and get a whole bunch of different versions of the manuscript that we wrote. So you will be able to do something similar to this and just have websites of stuff. You also don't need to necessarily have actual R code on all of these pages. It can just be regular text. Like if you go to this homepage, there's no R stuff here. This is just text. And you can just have text on every page if you want. So that's kind of what we're going to be looking at, is how to make stuff like this using R and R Markdown. All of the materials for today are accessible at a special website. If you've been to past past workshops with me, you know all the time. That website is here, this andhs.co/GPL interactive. Let me stick this in the chat here. This is the main hub for all of the content for today. So go ahead and go there. The slides are there. There's a ton of resources there for referencing how to use Markdown and R Markdown. Links to all of the activities that we're doing are there. So go ahead and use that link. And so go ahead and click on that link and you can see what we are going to be doing. This website as well was made with R Markdown, even though there's very little R code at this website. Oh, external site. Yes, I trust my stuff. Okay, yeah, so like if you click on slides, there's no R code here. These are just the slides that are just embedded here. If you click on these different menus here, that's all just text that I wrote. No R code, just a basic way of making a website and sticking it online and communicating stuff. Okay, so with that introduction, we're going to now move on to the next section here. About Markdown and universal writing. But before we start, ask me 1 or 2 questions in the chat before we start. I'll wait for 30 seconds and see if there are questions. Surely there are. Okay, so do I offer classes to lay people? This is that. We will go step by step through how to do this. You will write 0 R code today. I provide all of the code for you. You're really just copying and pasting, or it's already there and you're just clicking on buttons to run it. So you're not coding anything today. So that should hopefully be helpful. And then we will go step by step, piecing all of these things together, showing how this works. You'll get practice playing with this Markdown. So don't worry, you will not be super behind. And then Todd asks, on the web pages, does it compile the R code every time you visit the website or not? It does not. The way it works is when you when you create kind of a Markdown website, or a dashboard or whatever, um, you do that on your computer in RStudio or in RStudio Cloud. When you click on a button or type a command that says like build the website, it generates a complete folder of static HTML files, and then you put that somewhere. So let me show you what that looks like. If I come to, let me show you this actual thing. So teaching, workshops, GPL here. Okay, so that website that you're all looking at right now, these are the Markdown files that help build it. But what it generates is this folder here called site. And that site is just a bunch of HTML files, and I just upload that to a server somewhere. And so your departments likely have web server space. You just have to give them a folder and they stick it up there. The nice thing about that is there's no server configuration. If you've ever done any sort of web development with like WordPress or things like that, WordPress runs on a programming language called PHP. It requires a connection to a database called MySQL. And it's a complex beast to set up. The nice thing about this is it's just static HTML. So you can put it on your computer and then stick it online somewhere. And it loads really fast, because like it's just HTML. The server doesn't have to do any fancy stuff to generate the website for people. So good questions. Okay, let's get started talking about Markdown and universal writing and why we care about this. So you're all involved in research to some degree or another. Some of you might be running research labs. Some of you might be conducting analysis. Some of you might be writing up the research. Some of you might be communicating the research. The tricky part about research, though, is that writing about research is really, really complicated. If you're writing a novel, there's still some complexity there. You might have to map out your storyline, have different like biographies of all of your characters, timelines, things like that. But then the actual writing is just like you open up a Word file and start typing, and then you're done. With research, though, you have a ton of little pieces that all just kind of flow together, and you have to keep track of everything. There we go. For instance, there we go. There's a whole bunch of little tiny pieces. You have your data that you collect. You have the statistical results that you get out of Stata or SPSS or SAS or R or Excel or whatever you're using to analyze the data. You also have, if you're doing qualitative work, you have field work. You have your notes that you get from talking to people and from interviewing people. You have all of your analysis about that, all of your hand coding, everything like that. Finally, when you're starting to piece things together, you have pictures, you have tables, you have figures that come out of your stats programs, and then you have citations. If you're doing any sort of academic research, you have to put all sorts of citations in there. You have to care about the citation style. If you're following APA guidelines or Chicago guidelines or MLA guidelines, if you're submitting a report to a journal that says we want APA 7th edition, great, you do all of your citations for that. They reject you, and so you decide to send it to another journal, and they say we want Chicago 16th edition, which means you have to go back and change every one of your citations from APA to Chicago, and that's miserable. But there are better ways to handle all of this. You can piece all of these things together with your actual words, all magically. So the tricky part about this research writing is that every one of these things comes from a different place. And so you need to somehow keep track of that, so that you can know what's going on. So there are two general ways to handle all of this mess. There is something called the office model, which is where you put everything in one document. This doesn't mean like office, like you work in an office. This is like Microsoft Office. where you just have one big Word file called My Manuscript, and you write everything there. And you put all of your pictures there, you put all your tables there, you do everything just in that one document. If something changes, if you get a new version of an image, you have to go to your Word file, delete the existing picture, and then drag the new picture in there. So that's the office model. The other model is something I call the engineering model. And again, this doesn't mean you have to be an engineer to use it. This is just a different mindset. This mindset is that you just live with all of the bittiness of all of the different pieces and compile it all at the end. And so instead of trying to combine your text and your tables and your citations and everything in one document, leave them all as separate documents. And then when you're ready to compile the document, you just click on a button or type one command, and it merges everything for you automatically. So here's an example of the office model. Everything lives in this one file. You just drag stuff in, you make a table in Stata, you copy it, you paste it in here. You can, like, this is how we all work. This is a very standard way of typing stuff. You've all done this, you all do this. It's not a bad approach. It works. I do this for lots of things. The engineering model, on the other hand, looks something like this. Everything lives as separate little files. So you have your text in one document. You have your citations in another document. You have your tables in separate documents. You have your images and your figures in separate documents. And then what you do is you use a script to combine it all. And so it will go through and find all of your citations and then format those citations appropriately as APA or Chicago or whatever you need. It will insert the graphics that you need. It will insert the tables that you need and create a single document in the end, whether it be a PDF or a Word file or an HTML file or whatever. So that's kind of the engineering model approach. There is no one right way to do this. This office model, it can be clunky when you have like a big book project or a big research paper that has all sorts of stats in it. You'll inevitably forget to update one of your tables or one of your numbers. You'll say like the average income for this group is blah, and then like that'll be in the middle of some paragraph somewhere, and then you'll get new data and you'll forget to go change that. You've all run into that in the past. I have for sure. But even though this office model is clunky, the whole world runs on Word. All print publishing goes through Word at some point. And everybody writes in Word. Even if you're a strict engineering person that writes in plain text and runs everything plain text, I do that as much as possible. Most of my co-authors, I think only one does the same stuff I do. Everybody else works in Word. And so you have to be able to collaborate with them, and you still have to work in the Word world. You'll get comments and tracked changes in Word. Journals will demand Word files. Article or publication places will demand Word files. Everybody loves Word, so you still need to live in that world. So this engineering model is more fiddly, and it's kind of trickier to use initially before you get the hang of it. But there's a lot less cognitive load while using it. What that means is you don't need to remember to update your single number in the middle of a paragraph somewhere. You don't need to remember to delete all of your pictures and update the new pictures. You don't need to create a new scatter plot in Stata and then stare at your existing scatter plot and see if anything changed and make sure that it's the current version. You've probably done that before. You look for specific points to see if things have changed, and it's a mess. So the nice thing about this engineering model is you don't need to do any of that. If you have to switch all of your citations from APA to Chicago, you just change one line of code and it fixes itself. You don't have to go through and change every one of your citations and check your bibliography, anything like that. There's also a record of everything that you do, because everything is just in these separate pieces. You don't need to, if you're cleaning your data, you don't need to remember that you added a new column or got rid of specific rows. If you do that all just by hand, by clicking, you'll forget that you deleted 5 rows or something, and then you go back 6 months later and you can't remember why the results aren't working. But this lets you keep a log basically of everything you're doing. and your findings are reproducible by you in the future and by anybody else. And this is important because reproducibility is a tricky thing. And lots of academic journals have been trying to push for this in the past 5 to 10 years, specifically because of a few major news stories that came out 10 years ago about how lots of research has not been reproducible, where people publish stuff and then people try to get their code and recreate it and they can't. And nobody can recreate those findings, which is kind of dangerous, and actually dangerous. For instance, in 2010, there was a paper published by a couple economists, Carmen Reinhart and Kenneth Rogoff. And what they found in this paper, they're a couple of macroeconomists, so they look at GDP and inflation and things like that. What they found in their paper here is based on a whole bunch of different analysis they did. They found that having lots of national debt, especially in relation to national GDP, is bad. They found that if the ratio between debt to GDP is 90% or above, then you get negative GDP growth in the future, which you don't want. You want your economy to grow. And so, kind of the policy implication from this is to force your country to have low debt to GDP ratio and not take on national debt. This was published in 2010, which was in the middle of the European, the Great Recession in Europe, also the Great Recession here. And so, lots of policymakers throughout Europe and in the United States. For instance, this is the 2013 GOP House Budget Resolution written by Paul Ryan. He cites Reinhart and Rogoff here, saying we need to decrease national debt because if we have too high of a debt to GDP ratio, then we'll have negative economic growth. We don't want to do that. And so places like Greece and Ireland instituted austerity measures to help reduce national debt so that they can follow Reinhart and Rogoff here. So there were actually actual policy implications because of this research. So then what happened is this guy here, his name is Thomas Herndon. He was a PhD student at the time. One thing that lots of PhD level stats classes have you do is as a final project, they say, go find a research paper and replicate it. Because that's good practice. It lets you see what other people do with their code, lets you see what other people do with kind of how they analyze their data. And like I had to do a bunch of replications back when I was in grad school. I have my students do the same thing. It's a useful exercise. So this guy was assigned to replicate something. So he decided to do the Reinhart-Rogoff paper because it was an important paper. So he emailed Reinhart and Rogoff and said, can I see your code so I can recreate your paper? And they said, no. And then he kept emailing them and they kept saying, no, we don't want to share our data. We don't want to help. Like, no, it's just published. So believe it. So eventually he convinced them to, he eventually got the paper here or the data here. The great thing from this, this write-up about it is that Reinhart and Rogoff finally allowed researchers at UMass to look at the spreadsheet. And this is what they found. So this is their main table in the Reinhart-Rogoff paper. And what it shows is a whole bunch of countries over different time periods with their debt to GDP ratios and the economic growth that happened as a result. So they had this big table there. And so what this PhD student found is that they actually did their analysis not in R or Stata or anything. This was just in Excel. So he opened the Excel file and notice down in this average row here that there was something wrong. If you've ever used Excel, you probably have. If you want to do some sort of formula, you type equals, and then you can type like equals sum or equals average, and then you click on the first cell that you want and drag it down to the last cell. And then that gives you the average of that range of cells. What he discovered is that all of these averages here only included data from Finland down to the bottom. Whoever did the analysis in Excel did not click on Australia and drag down. The first 5 rows of this data were omitted from the average here because of an Excel mistake. So Thomas Herndon dragged it back up to the top and found this fun thing that having high debt to GDP ratio actually leads to lots of economic growth, 2% economic growth, which means like those austerity measures that were imposed on Greece and Ireland and like were not super helpful. And it's all because of this Excel mistake that was impossible to see unless you had the actual Excel file and then you clicked on the average cell and saw that it wasn't dragged up all the way. It was a mistake. That's just like an Excel typo right there, but it had like big ramifications for like national economies. Stuff like this happens all the time if things are not reproducible on purpose. For instance, in genetics research, um, in the genetics world, they also use Excel for everything. Everybody uses Excel for everything. There are a whole bunch of different genes and genetic markers that get recorded in spreadsheets. For instance, septin2 or this membrane-associated ring finger thing, or this number here. That's not an actual number. That is just some genetic marker thing. So the fun thing here, you can probably guess just looking at some of these. If you put this in Excel and press enter, Excel tries to be really smart. So what do you think happens if you type septin2 into Excel? In the chat, go ahead and somebody mention or somebody guess what would happen if you typed septin2. Yes, it will convert to September 2nd. Because Excel sees that and says, oh, they spelled September wrong, and they'll change it to September 2nd. Same thing with this. This will actually turn into March 1st. And this is a trickier one. Excel will see this and then think that it is a number. This E is programming language for scientific notation, like times 10 to the 13th power. So it would pretend that this is 2310009 with 13 zeros after it. So yeah, you open this in Excel and this is what happens. And you end up with genes that are actually dates and genetic markers that are actually giant numbers. And so sure, that's funny, but not. There was this paper that came out a couple years ago that found that 20% of genetics research between 2005 and 2015 had issues where it basically changed genetic information into dates. And then when you do analysis on that data, it doesn't know what to do with the dates. And so it just gets rid of those rows because it's not genes, it's dates. So yikes, that's like all over the place. And even if they didn't edit things, or if they didn't do their analysis in Excel, if they did their analysis like in SAS or Stata or whatever, just opening that in Excel, looking around and then closing it and accidentally saving it, or sometimes Excel has autosave on, just by opening that in Excel, Excel will do its magic to try to guess what those things are. And then you've ruined your data and you don't even know it. So that's dangerous. So in general, the general guidelines for this whole idea of reproducible research and having this universal writing stuff is to don't ever touch the raw data if possible. Like if you get an Excel file from somebody, you can look at it, cool, just don't save it. And don't like delete rows and delete columns and rearrange stuff and edit things there because stuff could go wrong and you could cause a recession in Greece. Use reproducible code, use documentation for the code, make it so that people understand what's going on, all of the changes that you made. And then try to use kind of more open formats instead of using Excel files. There's this thing called CSV, which stands for comma separated value. It's basically a plain text universal version of Excel or an Excel file. And it's less likely to suddenly change all your stuff into dates and mess stuff up. So, and even if somebody doesn't have Excel, they can still open the data on their computer, which is nice. So this does happen in real life. This is not just something that academics care about. So for instance, Airbnb published a paper a couple years ago just explaining how they do all of their internal analysis. And what they mentioned is they do all of their analysis in a thing called R Markdown, where they have the code and visualizations all combined with a report. And then they can click on a button and generate new reports for different departments. Everything is documented. Everything is Everything is described there. Everything is reproducible. Governments do this too. So the United Kingdom, they switched away from the old model as well a couple years ago, where they focus now on reproducible analysis. And so if you look at this top flow chart, this is what pretty much we all do, is they have some sort of data, they put it into some stats software, they do stuff with it, they generate tables or whatever, open that as a spreadsheet, copy the table from the spreadsheet into Word, and then convert from Word to PDF, and then put the PDF on the website and people can download it. You all do this. This is what you do. But then they switched from that to using R Markdown. So now this single document loads the data, runs all of the analysis, makes all of the pictures, and then they can put that resulting PDF or HTML file on their website and people can access it. So this does happen in real life. This is not just like a fun thing I'm trying to show you. This is like best practice. Lots of state and local governments are trying to move towards systems like this, just because it reduces the cognitive load and it reduces the possibility for lots of different errors. So as kind of a general overview of this process, this looks really scary, but don't worry, it's not if we take it into little pieces here. So if we start over here, you have some sort of data set. You open that data set in R or Stata or SAS or whatever, and you generate pictures, and here's your nice PDF that you made. Then you have some sort of idea. You have an article file where you type everything. Notice how the picture is not in the article. It's just kind of separate on your computer. You do all of your writing here. Then you use this magical thing called Pandoc I'll show you how to use that. That's a program that basically compiles all of these different pieces into a single file. So Pandoc is this magic glue that takes the references, takes the PDFs, takes the text, takes all of those different little bitty pieces, and then converts it to an HTML file or a Word file or a PDF or whatever, and just magically glues it all together. It can be a little bit more complicated. This is the same process. It's just that here you're doing all of your writing in something called R Markdown. And then when you click on a button, that then converts it all the way down to PDF and HTML and Word. But all of your writing happens in this fancier R Markdown file. And I'll show all sorts of examples of this. That's what the rest of this workshop is for. So this idea of universal writing is nice because it makes it really easy to type in just one kind of language and then have Pandoc handle all of the conversions. So we mentioned LaTeX or LaTeX at the beginning here. This is kind of the neat scientific typesetting language. Lots of people use this because it's been around for like 30 years, 40 years. It's a good way to do this engineering model. You basically either click on a button in a LaTeX editor or you run a command in your terminal and it stitches everything together. The issue with LaTeX, though, is one, it's like old and hard to use, and two, the whole world runs on Word. So if you make a really cool LaTeX file and it's beautiful and you send it to your PR department and say, make this fancy, they'll say, I want a Word file of this so that I can stick it in InDesign and make it match kind of our department guidelines. And then you're stuck because there's no easy way to convert from LaTeX into Word. LaTeX just kind of, it only makes PDFs. There are ways, but they're really, really hard to use and they're not consistent and it's miserable. So what if you want to be able to write a report in LaTeX, but also have an HTML file that you can put on your department's website and also have a Word file that can go into a journal later or go to the PR department so they can stick it in InDesign. Ordinarily, you'd have to have like 3 different parallel versions of your report, a LaTeX version, an HTML version, and a Word version. And that's miserable because if you have to change one thing, you have to change one thing across everything, and you don't want to do that. You also have to know how to use all 3 of those programs and how to type in them. So like if you want something to be bold, in LaTeX, you have to type this miserable thing, this text BF, curly brace, the thing you want to be bold, closing curly brace. In HTML, you use these tags. In a Word, you just click on the B button or press Control B. To make something a heading, you click on stuff. To make something a link, you click on stuff, or you use this HTML stuff. You have to know the syntax for all of that, and that's a lot of things to learn. If you want to do automatic citations, LaTeX does that. HTML doesn't. Word doesn't. If you want to do fancy math, LaTeX does that. That's why LaTeX was invented, for like fancy math. Good luck doing that in HTML or Word though. So the solution to this is to use something called a universal syntax, or this idea of Markdown, where you write with one simplified syntax and then let the computer handle the conversion into all of those different formats. So for instance, if you want something bold, you use two asterisks. If you want something to be a second level heading, you do 2 pound signs before. Guess what you do if you want a third level heading? You do 3 pound signs. If you want a first level heading, you do 1 pound sign. That's all you do. If you want something to be a link, you have the link text here in square brackets, and then the place it goes in curly brackets or in regular parentheses. If you want a citation, you just do this @ sign and then the citation key that you have in your reference manager. And then you can just do math. And so all you really need to know is this, and Markdown and Pandoc will automatically handle the conversion to all of those different outputs. So it will make it, if you're changing it to HTML, it will change this into whatever HTML tags you need. If you're making it go to PDF, it will change it to whatever LaTeX things need to happen. If you're going to Word, it will do whatever behind the scenes things Word needs to make that bold. So that is how this Markdown thing works, and we'll get practice with this in just a minute. So Pandoc is what makes this all work. Pandoc is not like an app on your computer. It's like a command line script. You don't actually see it, but it will convert a Markdown file to whatever. So if you say, I want an HTML version of my manuscript, you just type this, and it makes an HTML version. If you want a Word file, type this. If you want a PDF, you type that. And the nice thing about R Studio, which we'll be using today, is you don't actually have to type that. You just click on a button and it runs that for you. Okay, so that is what we're going to be doing today, is piecing all of these things together and getting practice with how to write using Markdown and how to insert different images and code and text and glue it all together here. Okay, so the neat thing about this is with this kind of more universal model, you don't actually need any specific programs to write in Markdown. You can use any text editor. You can write Markdown in like TextEdit or in Notepad. You can use something like Visual Studio Code. You can use RStudio. I actually, when I do take notes by hand, I take notes using Markdown. Like if I want something to be italicized while I'm writing, I put stars on either side. If I want it to be bold, I put 2 stars. If I have like headings in my handwritten notes, I'll do the pound signs to make like a first level heading and a second level heading. Because it's just kind of, I've been using it for so long, it's kind of a natural way of structuring text. And it works everywhere. So you use you Markdown, you use Pandoc, and then it all pieces together magically. So let's play with this so you can actually get your hands on using this syntax here. So go ahead and go to the resource website here. I'll put it in the link again. And at the top navigation bar here, there's a Markdown section. So there are 3 different pages here. There's a page for plain text writing resources. This is just a list of helpful external resources about how to use Markdown in general. There's links to different text editors, links to how to do citations. That's just for your reference. If you then look at the basic guide to Markdown, I have just kind of a list of how you write in Markdown and how you format things to get specific things. So for instance, if you want something to be italicized, you put stars around it. You can also put underscores around it. Some people do that. And then that will turn into italics. If you want something bold, use 2 asterisks or 2 underscores. That's bold. And so if you scroll through here, you can see all of the different methods for creating stuff, like links, adding images, making block quotes, making lists, adding a line if you want. And if you scroll further, it shows how to do math. It shows how to do tables and footnotes. So that's kind of a helpful guide. So I'd recommend having that open in a tab. And then I would open up another tab or another window with this third page here, this Markdown editor. This is a fancy little thing that I added for our workshop, where if you click on this button that says Edit with a Markdown Editor, it should pop open something like this. This won't save anywhere on your computer. This is just happening inside your browser. But what this lets you do is you can just delete the text here and start typing stuff. Like, here is some text, and that's just text. If I want something to be italicized, I use a star. So here are italics, and then I put a closing star. And if you notice on the right side, it shows you a preview of what is happening based on what you've typed in Markdown here. So here is some italics. You can also create bold text. So you use 2 stars, bold, like that. Okay, so go ahead and just play around a little bit. I'll give you 3 minutes to just type and click on stuff and play around, and then we'll go through that list of Markdown, that Markdown guide, and I'll show you more specific examples of how to do headings and images and math and code and stuff like that. But for now, just go ahead and start typing stuff. Try to make a list. Try to make some headings. I'll give you 3 minutes for that, and we'll come back in just a minute. Okay, so hopefully you got to click around a little bit. Let me reshare the links here. So that link right there. And then click on the Markdown menu bar, and then go to Markdown Editor. So again, this is all happening in your browser. Nothing is being saved to your computer. The nice thing about this Markdown stuff is that it's not just for academic writing. If you do any sort of blogging, WordPress lets you do Markdown. Pretty much all journalists use Markdown. So like the internal content management systems for like the Washington Post, the New York Times, Vox, places like that, they all write in Markdown. Because it's just a helpful way of writing stuff without having to write in Word or write in HTML or anything like that. It's a more universal thing. Lots of discussion forums online will have Markdown enabled things. Slack, if you use Slack, it basically uses Markdown. If you want to have something italicized in Slack, you do underscores around it. The weird thing about Slack is they have Markdown, but it's almost Markdown, and it's super annoying. Like if you do two or a single asterisk on either side in Slack, it'll actually turn it bold, even though it's supposed to be italics. And it, like people complain about it online all the time. They do it weird. But yeah, this is like normal. Everybody uses this stuff. It's not just academic research. It's all over the internet. So let's do some more basic examples here. So hopefully you've made italic stuff. If you do £1 here's a heading, and then £2 is like a subheading. You can do all of that there. So are there other Markdown editors readily accessible online? Yeah, so this right here is actually just an embedded version of this website here, stackedit.io. So if you go here, that is the same Markdown editor we're using. This is just like a mini version of it. If you look at that list of Markdown resources that I showed, that's on that website, there's a whole bunch of Markdown editors you can download to your computer. Again, you can also just do this in Notepad. Like it doesn't have to be anything fancy. The nice thing about this is that it lets you see side by side what's happening, and it does kind of make the text over here bigger, but that's just a thing they do. So if you want a list, here's a list of things. And so that's just with dashes. You can also use asterisks. If you want a numbered list, then you can say, here's a list of stuff. Okay, if you have just paragraphs, like you're not trying to do anything fancy, you just have to have an empty line in between each of your paragraphs. So here's another paragraph and another one. Okay, so notice there's just kind of this blank line here. That throws people off sometimes. Like you're used to indenting stuff, and so lots of my students will like hit a space 4 times and indent it. because you're supposed to indent stuff. Doing that actually formats things as code. So notice how here's another paragraph. I hit space 4 times. It's now formatting this code. So you don't want to do that. Don't worry about indenting. Just have empty lines, because when you convert this to Word, depending on how your styles are set up in Word, it can automatically indent stuff for you. So yeah, just doing stuff here. If you want a link, you can say, here's a link to Google. You can click on kind of these buttons up here to help generate the code, or we can just do it by hand. So if you look at the Markdown guide, the way you make a link is you have a square bracket and a closing square bracket, and then parentheses after it. And so we can say www.google.com, and that will convert to a link, just like that. Does Stack Overflow use the syntax? Yes. That Stack Edit website that I sent, that's created by Stack Overflow. That's the stack in Stack Edit. Okay, so that's how you do links. To do pictures, like an image, it's basically the same link syntax except you do an exclamation point, and then in square brackets you say, here's a caption, and then in parentheses you put the path to the image. So if this was on my computer and I had an image in the same folder, I could just say like thing.jpg, and it would put that picture. I don't have any pictures around. Let me find a picture really quick. We'll go to website for the workshop here. Yes. So I will just right click on this and say copy image link. And if I come back to here, I can then put the link there. There we go. Cool. Now I have a picture. Just like that. And the magic thing about this is, like, there's an HTML way of getting a picture in a document. There's a LaTeX way of getting a picture in a document. There's a Word way of getting a picture in a document. I don't need to know what those are. I just have to know the Markdown way, and then it will convert to whatever I need for me. So that, and then if you want like a horizontal line, you do 3 dashes, and now there's a line. Okay, so that's kind of the basic Markdown stuff. Some fancier things you can do. I'll show you math and tables and footnotes really quick, and then we'll move on to R Markdown. So to do math, there are a couple ways of doing math. You can do math in line, which just means like in the text. So I can say like, here's some text. Let me zoom in a little bit, see if that works. Okay, so I can say, here's some math stuff. The Pythagorean theorem says that, so Pythagorean theorem is that a squared plus b squared equals c squared, right? Is that's the triangle thing, I hope. So what we can do is actually format that as fancy math. So to do inline math, you do a $sign, because that, or you do, yeah, a $sign means now there will be math. So then I can say a squared, so that this caret sign right here, it's on the 6 key. If you do shift 6, that's how you do an exponent in this math language. So a squared plus b squared equals c squared, and then I do a closing $sign. So everything between those two $signs is math. And if you look over at the preview, notice how it formats the letters as fancy italics, because that's what you do with like variables in math. And we have exponents, and it looks all fancy. There's our fancy math just right there in the text. You can do that with like statsy things. You can say the beta 1 coefficient is blah. Okay, so you get the subscript 1. So there's the beta 1 coefficient from the regression that you run. So you can do all sorts of inline math. If you're familiar with LaTeX, this is just LaTeX math. The best resource for that is to go to Google and search for LaTeX math. That can sometimes be dangerous because LaTeX is also other things. So make sure you specify like LaTeX or LaTeX typesetting math or something like that, so you don't get like balloons and things like that. So That's how you do inline math. If you want a block formula, you do $2 as kind of the delimiters. So anything in between those $2 will show up centered. So that we can do the same thing. A squared plus B squared equals C squared. So now we have our Pythagorean theorem. Oh, we need an actual 2. We have our Pythagorean theorem right here inside kind of a block math formula here. There's fancier things you can do, like square roots. Wow. Ignore the typing here. So I can say like SQRT X, Y, with the curly brace there. So there's the square root of XY. Again, that's, you just have to Google LaTeX math and you'll be able to see the different syntax you can write. But the way you use it in Markdown is $1 if it's in line, $2 if it's as kind of a block formula. So that's math. Tables. If you look at the website, the shop website, there are a whole bunch of different ways of doing tables. You just type it like this. You can also use R to generate this stuff, so you don't have to hand type it. But so if I like copy this and into the editor here, it brought in these delimiter thingies. There's the table. Neat. There's also other ways of doing tables. I actually don't like this version of tables because it's harder to see like the columns. I like doing that kind of table because it just works. It looks nicer as you're writing it. You don't have to have everything perfectly lined up, like with spaces, and get these like these up and down symbols lined up. You can actually write the table like this and just have everything kind of not aligned, but it'll end up turning into a nice table. Okay. The last thing I'll show you is how to do footnotes. You can actually do that in Markdown. So we can say, here's some text, and we want to put a footnote there. So to do that, you use the special syntax. If you look at the guide, it shows you the syntax. You do this, the square brackets, and then you do this caret sign, and then some sort of note ID. It can be a number, it can be text, it can be whatever you want. So what we'll do is say, here's some text, and then square bracket, that thing, note. So it here in the little editor thing, it automatically kind of shifted it up. That's convenient. But over here, it doesn't know like what note it's going to. So later on in the document, anywhere in the document, it doesn't have to be right after the text. It can be at the end, whatever. We're going to say, here's what the note is, colon, something important. Okay, so what that changes into is the text with a number. And if you click on this one, it'll drop you down to the footnote. And if you click on this arrow, it'll bring you back up to the text. And so that's how you do it. Each one of these has to be unique. So if you want like a second note, you can't call it note because then it doesn't know what this thing refers to. So you could call it note 3 and have this be note 3, whatever. So that's basically just playing with Markdown. You can do cool stuff. So let's close that. Again, none of that is saved. It's just kind of in your browser, just a way of playing with stuff. So what we're going to do now is give you a little bit of practice actually playing with Markdown on your own more systematically. So if you go to the main page here for the workshop, which again, I will stick that in the chat here. And then click on this link here. It says there are a couple different RStudio projects. And this first one is called R Markdown Fun, because it will be fun. Click on that, and it should open up a new RStudio project called Georgia Policy Labs R Markdown Fun. So go ahead and open that. Let it open. If you haven't created an RStudio account, do that really quick. You should be able to connect it with like your Google account. So if you're logged into Gmail, you don't have to log into anything new. So let that open. I'll give you 30 seconds or so. Once it's open, there is a Markdown file in the Files panel here called 01recreateme.md. That .md just means markdown. And then click on that to open it up here. We'll wait for 30 seconds for everybody to get here. Okay, yeah, so how to get here, if you go to the main page for the workshop, you're going to want to click on this first link here called R Markdown Fun. And then once you're there, if you look in the Files panel, there's a thing that says 01 recreate me.md. If you click on that, it should open up the text. Okay, so what we're going to do is if you also look in the Files panel, there's a file here called recreateme.pdf. If you click on that, it should open up a new tab with a PDF. This is what a LaTeX file looks like with this specific font. Probably seen academic-y looking papers that look like this. So what I want you to do is we're going to take 10 minutes. And you are going to try to recreate this paper the way it's formatted using the text that I've already given you. So this is just the beginning of A Tale of Two Cities. I copied from the internet here. So what I want you to do is recreate this thing. Make things bold, add a footnote, because there's a footnote there. Make this a block quote, and kind of compare this PDF with what you have in RStudio here. If you want to preview it, which you probably want to do, because before, when we were using that stack edit thing in the browser, you could see side by side what was happening. Here, there's no side by side preview. So if we, for instance, want this to be bold, we can put 2 asterisks and 2 asterisks. It does kind of change it blue. That's convenient. But we don't really know if that's bold or italics or whatever. So what you can do is if you click on this preview button at the top of the editing window, that should convert it to HTML. Or actually, it converted it to PDF. That's neat. So here's what we have so far. We've got bold. That first part of the sentence is bold. So we can close that PDF, come back here and make changes. If you don't want to preview as a PDF, you can actually click on this little drop-down menu next to preview and tell it to preview as HTML. And that actually goes a little bit faster. And here's the HTML version. See, it's bold, just like it should be. Okay, so take the next, it will go to 10:25. So it's actually 7 minutes. So go ahead and try to recreate this paper here with the headings and the block quotes and the footnotes and the picture and everything, and the math that's later on there. Try to make that using this markdown file that I've given you. And then once we're done, we'll show the answers and see what that looks like. But this is a good way to practice how to actually format your text. So 1, 2, 3, go. Okay, so if you've also noticed, this very top part is a little bit different from the rest of the document. It's set off with these 3 dashes, 3 dashes at the top and then 3 dashes at the end here. This is called the metadata. It's data about your document. And that's where things like the author name and the title and the date, all of those things go there. As well as things that are important for the rest of the document, such as connecting it to a bibliography file. Generally, you use something called a bibtec file, which again is used by LaTeX, but it's spelled like this in the chat, bibtex. You'll want to pronounce it bibtex, but you have to do the dumb LaTeX thing, so it's bibtec. If you look at the Markdown resources at the website, I show a few different programs you can use to write these types of citation databases. They're really just plain text files. Like if you click on references.bib here in the files panel, this is what it looks like, where you have like, here's an article and here's its ID and the author, the journal, the month, the number, all of that stuff. But you don't ever want to write this by hand because that's miserable. And so there are programs that let you edit these things. If you're also familiar with Zotero, which is a citation manager that's free and lots of people use that, Zotero can connect to our Markdown or to Markdown files, and you can do citations from Zotero instead of having this bib file. But that's what you have here. And then if you notice the CSL, that stands for Citation Style Language. This is the definition of how to translate these references into something. So this is Chicago author date. And if you look in the CSL folder, I included a few different ones. So there's Chicago Note Bibliography, there's APA. So if I want to switch from Chicago to APA, I just have to point it at this other citation style language file, and it will use APA instead. Okay, so if we look back at this final version here, you'll notice that there's an image at the beginning. Hopefully you got the image and the block quote and the footnote. So what we're going to do is just look at the answers here. So if we look at the answers folder and click on example.md, here is what ended up happening. Let's zoom in a little bit so you can see better. Okay, so to get that initial picture, you use that type of formatting here, where you say, here's the caption in the square brackets, and then in the parentheses, you give the path to that picture, which was in the image folder. And then this exclamation mark at the beginning makes it an image. If there wasn't one of those there, that would still work. It would just make a link from, like this would be a clickable link. You could click on A Tale of Two Cities and then it would show the image. But we want the image to just be there. Bold, we use 2 asterisks there to get a footnote, which is what we had here, where it says this number 1 here. This is a super famous part. We use this square brackets with this caret sign and then some sort of ID for the note. And then later on in the document, we put the actual note in there. To make something a block quote, you use just that greater than sign, or less than, that's greater than, I guess. That sign that goes this way. You want that sign there. So to add a heading, just 1 pound sign. If you want a subheading, we can scroll down. There's a subheading with 2 pound signs. You can go up to 6 levels of headings if you want. I don't know if like that, if you're a lawyer, maybe you use like 6 levels of headings and it gets super detailed, but mostly you're going to go like 1 through 3 and that's it. So let's see what else we wanted. So we have, we wanted this to be this mirror messages in the earthly order of events. We want that to be like code. So according to our Markdown guide, we do that with this backtick symbol, which is on your keyboard next to the 1, to the left of the 1. So you put a backtick at the beginning and a backtick at the end, and that makes it formatted as code. Making this a list, you just hit enter a bunch of times and put these dashes there. That makes it a list. To make things a numbered list, you do the same thing, but instead of dashes, you do 1 and 2 and 3 and 4. Cool. So scroll down. What else did we have? Oh yeah, the math at the end. So that was just headings and lists. All right, so the math, we have math in the middle of a sentence and math as a block. So if we come back to the Markdown file, in the middle of the sentence, you put the math in between dollar signs. And if you want it as a standalone block equation, you put it between 2 dollar signs. One thing that gets people confused a lot is, what if you're actually using dollars? Like you say, here's like the price of bananas is $10. That will mess stuff up because when it converts from Markdown to HTML or whatever, it's going to see this dollar sign and think that that's the beginning of a math equation. And then it's going to look for a closing dollar sign over here. And so it's going to format all of this 10, here's some math in the middle of the sentence, like, it's going to pretend that that is math and format it as math. You don't want that. We want this to actually be a real dollar sign, not a kind of the border for math. So to tell it to be a real dollar sign, you put a backslash before it. Kind of a weird little trick you have to do. That backslash will disappear when it converts to HTML or to PDF or to whatever, and it'll put the real dollar sign in there, and it won't treat it as math. So that's that's a thing you have to do. And then the table, this I just copied from the Markdown guide on the workshop website and then just changed stuff. So that's how you do a table. And then the last thing, you may have missed it because it's just kind of hidden in here. There's a citation at the end of this paragraph, this Heist 2019 thing. You may have hand typed that. You may have not seen it. It's kind of hidden there. But to do that, rather than just hand typing it, if you notice at the end, there's references. There's an actual bibliographic entry there based on Chicago 16th edition. To do that, because at the top we connected this document to our bibliography file, all we have to do is come to wherever I stuck the citation. Here it is. So in square brackets, this is at that Markdown guide I had, use this @ sign, and then you use the name of the reference, the ID of the reference that's in that references file. Or if you're using Zotero, it's kind of the ID of the entry in Zotero. And that's all I have to do. It will automatically stick the bibliography entry at the end. It will format this however it needs to be. So right now, we're saying this is Chicago author date. But if I look, let's just for fun, look at the other things. We can say, I actually want this to be APA. So if I delete this Chicago author date and say APA, save it, let's preview it. And it will do its magic conversion. Fascinating. It says there is no APA thing there. Oh, it's because I'm in the wrong folder. This example.md is in the answers folder, so it's looking for a folder in answers called CSL, and there isn't one there. So we can actually just do .. That means go back a level. So it's going to not look in that answers folder anymore. It's going to look back at the main folder and then look at CSL. And we have to do the same thing for references here, .. back. So now if we preview it, it should work. And we should get APA. Same thing with the image, .. Okay. Silly paths. Voila. If we scroll down to the end, this is APA style. You can tell because it uses the initial instead of the name. So that is that. And then if we want that to be a footnote instead, rather than think apa.csl, we can do Chicago note bibliography .csl. Whoa. Except we have to spell it right, not bibliography. Note bibliography. Preview. So now if we scroll down, this is no longer a parenthetical citation. It is a footnote using Chicago style notation. And if we scroll down, there's the Chicago bibliography, all just automatically. Okay, so that's just regular Markdown converting to all of these different formats. Todd has a question. How do you compile the MD file? So far, we've just been clicking on this preview button. If you notice, it actually generates this awful super long command here. That's one command that is run in terminal. This initial thing right here is pandoc. That's the program that is converting it. And so what it's actually doing is converting it. And then if you look in your files panel, it is creating these files for you. So like if we look at answers, for instance, it made the PDF file there. So preview shows it, but it also generates the file and sticks it in that same folder. So it made that PDF using this long hairy command thing here that you don't have to type. It made the PDF. So if we want an HTML version of that example, I can click on down here, preview HTML. It will do its thing. Here is HTML, neat. And then if I look here, now I have an HTML file in that folder, and it has now been converted. If I want a Word version of it, you do the same thing. You click on preview Word, it'll make a Word file there. Okay, so that's how you do that with just regular Markdown. There's no R involved here. This is just typing stuff in a text editor and formatting stuff and then clicking on preview. And no code other than like typing stuff in an editor. Okay, so that is Markdown. You've been exposed to it now. And as you get the hang of it, if you just kind of start writing stuff as Markdown, it's a neat way of just writing and making things universally accessible. You don't ever need to worry about writing in LaTeX anymore or in HTML. You can just write in Markdown, convert it to whatever you need in the end. Okay, so what we're going to do next is switch gears a little bit to something called R Markdown. So you're familiar with Markdown now. You've seen how to format things with headings and with bolds and with italics and footnotes and all of this stuff. But we can also take this text and mix it with R code. Or if you're familiar with Python, you can mix it with Python code. There's even a way to mix Stata code in with a document. It doesn't work super well. There's not a lot of support. Stata itself, they're kind of working on a way of mixing Stata and text in like Stata 17 and Stata 18. It's not super developed. Maybe someday they'll get around to it, but definitely this all works with R. So what we're going to do, go ahead and click on, in the main project folder here, click on the file called 02 Penguins. And it should open up a new file here in the editor window. The only difference between these two files, this one is .md, this one is .rmd. They're still just plain text files. You can open this in Notepad, you can open this in Visual Studio Code, you can open this wherever. It's not like a magical file. It still looks like a regular Markdown file. Like if we look back at example.md, there's this top matter here, this front matter, this metadata between these three dashes. If you look at the R Markdown file, it still has 3 dashes with title, author, and date, and things like that. If you scroll down a little bit, it still looks like just regular Markdown text. That's just text, it's written. Here's a list of stuff. And that's what we can see. It's just regular Markdown. The only new thing we really have, notice here, the species, island, bill length, things like that, they're in these backticks, which means they'll be formatted as code. These are just variables in a set that we're just describing here. So that's still just regular Markdown. This is a picture using just regular Markdown syntax here. But something that's new are these gray areas here. These things that happen between triple backticks, and then it has this curly thing with R, and then a closing curly thing, and then closing triple backticks. Those are something called code chunks, or just R chunks. So anything in between these triple backticks with this curly brace R thing, that is R code that you can actually run. So if you click on this play button, there's this green button in the top corner. Click on that for this second chunk here where it says library tidyverse, library scales, library broom. What that's going to do is run all of the code in that chunk there, right here in your document. And it should show a whole bunch of text like this that's miserable. You can actually kind of close this window if you click on this X, clear output. Okay, and so what that did is it let us load these different libraries that you use in R for doing different analysis. And then we loaded a data set and we named it Penguins Raw. And if you look in the environment panel here in R, there's a data set here called Penguins Raw. And if you click on it, it should open up a new tab. And here's our data set of penguins. So this is like 300 penguins from 3 different islands in Antarctica. People collected data about their bill length and bill depth and flipper length and how heavy they are and a whole bunch of stuff like that. So this is the data that we're going to be playing with. It's free, neat, fun data to just play with. So that is our data file. So then here I describe this. I found all of this information at the website where this penguins data was. And then I just wrote this by hand, like this wasn't magically generated. One of the variables in here is this idea of bill depth. If we look back here, one of the columns is bill depth in millimeters. What that means, apparently, is the height of the bill. So bill length goes from like the tip of their bill to where it hits their face. Bill depth is from the top of the bill to the bottom of the bill. So that's what bill depth means. And to help show people what that is, we include a picture because why not? So as you scroll down, you can see that there's a section here called cleaning the data. And then there's a chunk that show like different chunks here that show how to clean the data. But the really neat thing about this is notice how there's just text. There's no R code here. This is just me saying, we're going to clean the data now. And then there's a chunk where it actually cleans the data. And then we say, we need to do specific things to clean the data. And then there's a chunk where we do that. And then, so you're just kind of going through this process of mixing text with R code. And then there's another heading here called exploratory analysis, and then a second level heading called penguin weight by species. So it's a very structured document with headings and subheadings, with things that are italicized. There's lists, there's all of that, just regular markdown text, but mixed in with all of the text is code that generates stuff. This chunk right here will generate a plot, and then it will show that in the final document. So before we go too far down, what I want to do is we're going to knit this document. So before with the markdown file, we were clicking on preview and that was generating and compiling the markdown file. In the R Markdown world, what that's called is knitting, because it's basically taking the code, it's running all of those chunks, taking the output from those chunks and combining it with the text. And so it's kind of knitting it together. That's the metaphor they use. So we're going to knit this file as HTML. So we're going to click on this down arrow. We're going to knit to HTML. And what that does is it goes through and runs each of these chunks and then combines it with the markdown text that we have and creates a document. So here's our penguins document. It has the code directly here in the document. It has all of the output from the code. We can fix that in a minute. But if you scroll down a little bit more, here's the list that we typed. Here's the list of all the different variables formatted as code. There's our picture of a penguin and build depth, neat. Scroll down a little bit more, it says cleaning the data. There's our cleaning the data section. There's a picture. Scroll down a little bit more. Here's where we actually clean the data. Here's another picture. There's no missing values anymore. Scroll down a little bit more. Here's penguin weight by species. So you have text, you have code, and you have the results of the code here. Whether it be a picture, it could be a table, it can be text, it can be whatever you need, but it's all in one single document. If you scroll down more, you can see that there's some math in there for a regression model, and then the code for running the model, and then the output from the model. You can make this be a table. So you have a full document right here with the R code directly in the document. So that's just kind of a super basic example of what an R Markdown file looks like. Again, the main concept here is you have text, and then you have chunks of code interspersed throughout the text where you do your analysis, and then it will combine all of the stuff in the end when you knit. So I gave you all of these chunks of code. If you want to insert your own chunk of code, rather than type, like if I want a chunk right here, I could type backtick, 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 curly thing, R, closing curly thing, enter, enter, backtick, backtick, backtick. That's miserable. And if I forget one of the backticks, then it messes the whole document up, and that's not fun. And so what you can do instead, we'll delete that. This green button right here at the top of the editor window lets you insert a chunk. You can insert an R chunk. You can actually have Python chunks interspersed. So you can, this is a super magical thing. If you ever do Python stuff, you can have Python data analysis and then have that transfer the data into R, and then you can show it with like ggplot, and then you can pass it back to Python. You can basically mix R and Python and Stata and everything in a single document, which is like mind-blowing. So I can just click on R and it will insert that R chunk for me. There's a keyboard shortcut for it too. If you hover over that green button, it tells you here, it says it's Command Option I, or it's going to be Control Alt I if you're on Windows. So that's how you do an R chunk. So what we're going to do really quick is clean this up a bit. So again, let's knit. Let me raise this up a little bit so you can see what's happening when you're knitting. So when you knit, you'll see this fancy scrolling thing. What it's doing is going through each chunk and running it. And so if there are ever any problems, if there's an error in one of the chunks, it'll tell you what chunk it is that has the issue, and you can go back and fix it. And then here's the results. This is neat, but this isn't like great for distributing to people or to show, like, for showing this to the public, because it's got all of these warning messages, and just messages, just helpful messages saying what R is doing behind the scenes. Nobody cares what that is. You do if you're like writing the code and like doing the actual analysis, but when you're like communicating these results, nobody needs to see all of this information there. That's just kind of clogging up the document here. So each chunk has specific options that you can set. So if you scroll up to the second chunk here at line 11 here, where we load the libraries, load the data, what we can do is if you click on the gear icon for that chunk, it lets you modify the chunk options. And you can do a few different things here. We can tell it to show warnings or not show warnings. So you can toggle that warning thing. And if you notice what happens over in the chunk itself, it changes the text here. So now it says warning equals false. If I click on this again, it should say warning equals true. We want it to be false. We don't want to see those warnings. We can also tell it to not show the messages. And then the last thing we can do is we can actually name this chunk, which helps with navigation in the document. So what we can do is just say this is load libraries. You can name it whatever you want, you just can't use spaces. So we'll just call this load-libraries. If I click on apply, we now have a chunk here called load libraries where no messages and no warnings will show up. So that chunk name is convenient so you can see what the chunk is actually doing. But the other reason why this is important is if you look down at the bottom of this editor window, there's this green symbol here and it says chunk 2 load libraries. If you click on that, that's actually a table of contents for your document based on the headings and the chunks that you have in the document. So we have, this is our penguins document. There's a chunk called setup right there. There's a chunk called load libraries, which is called load libraries because that's what we called it. Notice these other chunks don't have names. I have no clue what's happening in chunk 5 here. If I click on it, it'll take me down to it. Oh, it's writing a CSV file. Great. I can actually name that chunk and we'll say write data. And if I click on apply, now it has a name for that chunk. And if I click on the little table of contents thing, now I know that chunk 5 here is the write data chunk. So it's generally best practice to name all of your chunks so that you know what's going on and you can jump around and navigate easier. So let's go ahead and knit this again now that we've turned off the messages and warnings and see what happens. Knit. Did I click on it? I did not. Knit. We should have a much nicer, cleaner output. Yep. All right. So look right here. Instead of having all of that extra text that spat out when you knitted, it just has the code here. It ran the code, which is nice, but it's not showing all of that extra output. So if you scroll down, you can see this next code, this next chunk where we say gg miss var to look at the missing variables. There's a warning. We don't want that warning, so we can turn it off. So if we scroll down to where that happens, which should be this chunk here, we can come into the gear and say, don't show warnings. Warning equals false. Could also name it, but for the sake of time, I'm not going to name it. You also don't have to use that gear icon. You can just write warning equals false, like just type it there. I generally do that because you don't need to click on stuff. So now if I knit this thing, there should be no warnings. And if we scroll down, no warnings. Now it's nice and clean. So it has the code there, and then it has a picture there. Todd asks, can you turn off messages for all chunks in the document all at once? Yes, you can. I generally don't recommend it because if there are errors or warnings, I generally want to know. I will turn them off for chunks that I know generate the warnings. Like for whatever reason, this tidyverse library, when you load it, it's a very talkative package. It gives a ton of messages. And so I know that that will generate messages, and so I turn it off. Um, if I have a chunk where I like this chunk should not create any, or that one will, this chunk should not create any messages or errors or warnings. And so I don't turn it off because if it does create a message or a warning, then that means something's probably wrong. And so I don't want that to happen. Um, but you can also turn it off kind of globally. If you look at the very top of the document, there's the setup chunk. This cryptic code here, I never actually type this because I can never remember how to type it. But this lets you set chunk options for the whole document. So it already sets one, this echo equals true. That means it's going to show the code for each of these chunks. If I change that to echo equals false, then there will be no code in the document. You can also say echo equals false for specific chunks. So if I come here and say echo equals false, what that means is it will run that code, but it won't actually show it in the document. So if we knit it, let's show an example. If we knit, notice at the beginning, there's no code here that says library tidyverse, load the penguins data. None of that is there anymore because we said echo equals false. So if we take that off, it'll show again. But if I say echo equals false right here, this is the global options. And so now there will be no code in the document whatsoever. Nobody will be able to tell that this was made in R. This is something I actually have my students do in my stats classes. For their final reports, they have to write their final report as an R Markdown file, and they have to turn in two versions of their report. They have to turn in a version with all of the code in it, and they have to turn in a version with no code in it that is publicly kind of digestible. Like this is something you could publish online because there's no code in here. It's just text, images, math, table, text, picture, math. Like nobody knows that this was made in R. This is something that you can then distribute to the world. And the only difference between like to do that, you just switch this from echo equals false to echo equals true, and then it changes. If you want messages to be off globally, you do that here. You say message equals false. And now all messages will be off for all the chunks. If you want all warnings to be off, you say warning equals false. And that will also turn off all the warnings. So that's how you do this global stuff. The way I get this code, because I can never remember how to type this, is I actually go to File, New File, R Markdown, and I just make a blank R Markdown file. And the convenient thing about that is it includes like template code just saying like, this is an R Markdown file. And right here at the beginning, it has that setup chunk. And so I just copy that and paste it into my own document because I can never remember how to type this thing. So that's totally normal to just copy and paste. Okay, so that is an R Markdown file. Again, it's just text with code interspersed. In general, you want your code, you want your output to be as clean as possible and as pretty as possible so that it's nice and clean and understandable. A couple other fun things we can do here. So I at the beginning I mentioned that sometimes if you have if you're saying like the average income for this group is blah and you write an actual number, you have to remember to go back later and change that number so that it reflects kind of your current data. And if you forget, which is very common, you'll have wrong numbers in your file. What you can actually do, so we've been doing chunks which show our output kind of as a whole block of text. So an image will show up there or text will show up there. But you can also do our chunks in line, meaning like directly in the text here. So for instance, see how what I'm going to do is right here between 2007 and 2009. I'm going to hit space, and I'm going to type 2 backticks. This is just the way you do code. Like, here's code. This is the same thing that we did for species and island and bill length. If I knit this, it would put the actual words, here's code, but format it as like monospaced font. But if I want this to be R code that shows up in the middle of that sentence there, I can put an R at the beginning and then a space. And now whatever is in here is R code and it will run. So if I say 2 plus 2, watch what happens when I knit this thing. It should say 4. And it won't say 2 plus 2. It's actually going to run that as if it is R code. So if I scroll down, or it's right there, between 2007 and 2009, 4. That was automatically generated, which is super cool. You probably wouldn't want to actually do that in real life because just type 4, but that is R code that is there. There's a variable in R called pi, which has kind of pi in it. So if we, like, for instance, there's 3.141593, whatever. If I knit this now, it would put pi in there. If I wanted to round pi to 2 digits, for instance, we can actually just type that here, round pi to 2 digits. So now we have our code directly in our sentence here. If I knit it, it should say between 2007 and 2009, 3.14. 3.14. Cool. So those are kind of like not great examples because who cares about 3.14? But what is super helpful is if you scroll down a little bit more in the document, you can see there's this chunk here at line 74-ish where I generate some summary statistics of these penguins in a data set called Penguin Details. And we can actually look at it, Penguin Details here. So it's just this mini table here. It says, here's these 3 different species. Here's their average weight, average build depth, and average flipper length. So I made that little summary table. Then what I do is I extract those numbers. So I want just the Gen 2 penguin weight. And so I use this command to extract that number out of that table. So now I have kind of this variable that has the Gen 2 weight in it. So if I scroll down a little bit more to the actual text, you can see it says it looks like the Gen 2 penguins are heavier on average than the other 2 species. Gen 2 penguins weigh an average of, and then there's that Gen 2 weight. And it's going to format it using a comma because it has like thousands in it. So it's going to put a comma appropriately positioned there. And the cool thing about that is I didn't hand type any numbers. So if I get new penguin data, the average weight will just show up here in the middle of the text. And so what we can do is if we knit it, let's scroll down and see what that looks like. So we scroll down to the average stuff. So look, it says, it looks like Gen 2 penguins are heavier, substantially so. Gen 2 penguins weigh an average of 5,092 grams, while these other 2 weigh an average of 3,700 and 3,700. Those numbers were automatically generated. I didn't have to type them. Again, if anything ever changes, those will automatically change too, which is like super magical. All of this, nobody needs to see that. Even if I'm like I probably just want to turn this chunk off. I still need it to run, but all of this extraction here to get the actual numbers pulled out of that summary table, I can actually just turn that off by either saying echo equals off, or I can say include equals false. And then it won't include that chunk. It'll still run it, but now that won't show up. That's just kind of some behind the scenes stuff to generate these numbers, and then it will show up. So now if we scroll down, we should see, here it is. Yeah, I can't find it because it's not there. So we have this cool picture, and then it says, here's our paragraph that we wrote about average weight, but you can't see the code that generated all of these numbers there. It's just kind of hidden there behind the scenes. Makes for a much cleaner document, and it lets you put numbers directly in there. That works for anything. So like later on in this document, there's a regression model. and I extracted the coefficients from the regression model. So you can actually just write this up and say like a 1 millimeter increase in build depth is associated with a negative 193 gram decrease in body weight. That negative 193 comes from the regression model, but that was automatically generated and placed in there. If I want the p-value in there or talking about statistical significance, I can also extract the p-value, put it directly in the text. And so in theory, you never have to write actual numbers again. You just have to extract them from the R pieces and then show them in the document, which creates far more accurate results. This picture automatically generated. I don't have to drag it into Word. I don't have to compare this picture with another picture to see if anything changed. It's just, here's the most recent version there directly in the document. So that is basically how you use R Markdown. If you look at the answers folder, there's a Penguin's finished R Markdown file that's the same document, just with all of the chunks cleaned up. You can change the dimensions of the different figures. Like if you want this picture to be shorter and wider, in the gear icon, you can click on use custom figure size, and you can have custom width and custom height. This Penguin's finished file shows basically all of that. So that is how you use R Markdown in a single document. So what we're going to do now is take a 3-minute break. When we come back, I'll show you how you can use these same R Markdown principles to make websites and to make dashboards. And it should go fairly quick because both of those things basically just involve Markdown files with headings and text, and R if you want in a chunk, but you don't have to. So it should go fairly quick and should be fun to do. So 3 minutes, come back. If you have any questions, put them in the chat and we'll answer them after the little break here. So we'll see you back here in 3 minutes. Okay, welcome back. So just as a quick example, just to show what this looks like. Okay, so here's what a Markdown file looks like in real life. Here's an R Markdown file for one of my research projects. So if you notice this top area, this metadata section is pretty extensive. It has a title, short title, all this author information. But then once you get down to here, see chunks. Here's the chunks where it loads all the libraries. And then here's just text. This is Markdown. Here's different citations we have. And then more Markdown. And then more Markdown because this is a long paper. But then eventually it starts adding more chunks after the lit review here. There's some chunks. So there's a table that we show. Here's another table that we show. So again, it's just regular text that we write, but then merged in with all of that text is code. And then it results in kind of a compiled final document. And that's kind of the gold standard for this reproducible research with stats. And it's what I encourage people to use because it's a cool way of analyzing data. Okay, so that is how you create kind of single documents, just a single report or a single paper or something like that. But what if you want to have kind of a more complicated output? If you want an entire website with lots of different files all showing different parts of your research. For instance, these different websites here that we showed at the beginning, or even our workshop website, which is here. Let's go to the workshop website. Okay, so this right here, I'd mentioned at the beginning that this was made with just R Markdown. Even though there's no R on this page, this is just, there's no R code, I don't think anywhere in this whole website. This is just text. But I was able to use an R package to create kind of this entire website automatically. And the way you do that, so if you go ahead and click on R Markdown at the top menu bar here, this R Markdown interactivity, there's a basic guide to R Markdown that kind of has an overview of what we just looked at with that Penguins file. But then there's also a page for websites. So if you click on the websites page, you'll see there's a list of different ways of creating an actual website with R. they go from the easiest to the most complex. So the easiest way is just to have a single R Markdown file that turns into an HTML file. You can then stick that HTML file on the internet somewhere. It's a blog post, it's whatever you want. It's just a single standalone file. That's the easiest way to make a website. It's a single page website. The next step up, which is what we're going to do right now, is creating something called an R Markdown website, where instead of knitting a single file, what an R Markdown website does is it knits all of the R Markdown files in a single folder. So it'll look through and it'll go alphabetically and find the first R Markdown file, knit it, and then go to the next one, knit it. And so it'll create a whole bunch of HTML files, and then it will stitch them all together as a single website. And that's what this is right here. So this websites with R Markdown file right here, this was just an R Markdown file on my computer. When I clicked on a button, it knit this thing because it was one of the R Markdown files in the folder. So that's what I do for all of my little statistical analysis notebooks. Moving up this ladder of complexity thing here, there's a package called Distill that lets you make a website, but fancier and more complicated. You can actually have like nested folders. You can have a folder for research and a folder for publications and a folder for whatever, and it'll knit all of the R Markdown files in those subfolders. This R Markdown websites thing won't. It only knits stuff in a single folder. And then the last option is this thing called Blogdown that's the most complex, but also the most powerful. This is what I use for creating all of like my different course websites here at GSU. So this is a class I teach in program evaluation. This again is all just Markdown, but I can click on like content here. I can go to our first class session, and here's all of the readings that students have to do. Here are the slides from our class session. Here are the videos on YouTube for that class session, so you can watch and participate in the class if you want. It's all here. But this was all generated through a whole bunch of Markdown files that turned into this. So that's the most complex. It's hard to use. It takes a while. It's a very steep learning curve. But for kind of at the most basic level, you use this thing called R Markdown websites. And the easiest way to do this and to learn this is to really just kind of play with it. If you click on I have two different links here. There's this R Markdown websites link and then the full documentation link. If you click on each of those, the first one, this R Markdown websites link, is just kind of a basic overview of how it works with kind of an example of how to get started with like a 3-page little website. That's a useful way for getting started. The next page, the full documentation, this has the full documentation of all the settings you can do to make the website. Really, the easiest thing to do is just to play with it. So we're going to play with it. We have to do it in a separate RStudio project because we want it to combine all of the different R Markdown files that are in a specific folder. We don't want it to do the penguins thing. We don't want it to do the Tale of Two Cities thing. We just want a separate project. So if you go back to the main workshop website here, there's a second RStudio project you can open called R Markdown websites. So go ahead and click on that, and it should open up a new R Markdown websites thing. I will put it in the chat as well. So you can click on that link and it'll open up a new RStudio instance ready for websiting. Okay, so if you look in the files panel in this R Markdown websites project, you'll notice there are a few R Markdown files now. And I named them like 00 clean data, 01 explore data, 02 model data, and then I have about, conclusion, and index. All you really technically need for this to work is the index page. That's the home page. That's the main page that you see when you go to this website. So if I click on index.rmd, it's just a standard simple markdown file. It says, welcome to this very important penguin research. And then it has this R code here to show an image on the page. This is the R way of doing it. I could also use the markdown way of doing it, which is the exclamation mark, square brackets, parentheses. The only issue with doing that is that you can't control the width of the image. And so like if I only want it to be 50% wide because it's big, I can control that with chunk options. You can't do that with regular, just the Markdown with the exclamation mark, square brackets, parentheses. And so you can do it with this R way here. So that will be the home page. The reason I have these numbers here is because when I build this website, it goes and runs each of the R Markdown files in alphabetical order. And so I want it to run clean data before it runs explore data and model data. Because clean data, if you click on it, this is the same stuff that we had in the R Markdown file from before. This is just separated into separate pieces now. So this clean data file will load the raw CSV file. It will clean it up, get rid of missing rows, and then it will save it as a clean version. So that's what that file is doing. Then we want to use that clean version in later R Markdown files. So if I click on Explore Data and scroll down a little bit, notice how we are now reading that clean CSV file that we made in the clean data file. So again, I put these numbers here. That's not required. I just did that so that when you build the website, it knows run this one first, then run this one, then run this one. And then after that, it doesn't matter. I think about doesn't have any R code in it. It's just text. So it doesn't need anything before it. Conclusion, I think, is just text. Yeah. Okay, so it's a bunch of R Markdown files. The way they are stitched together, if you notice, there's one magical file here at the very top called _site.yml. That stands for YAML, YAML, which is a type of markup language for like making settings. This is the same stuff that you see at the top of each of the Markdown files in the metadata. This is just a standalone metadata thing. And this is where you tell R Markdown how it's going to stitch everything together. So we want a navigation bar at the top. We want the title of the navigation bar to be penguins. And then along the left side of the navigation bar, we want it to have some links. We want it to have a link to home and about and data cleaning and explore data, etc. And it's going to link to the HTML version, like the knitted version of the about page and the knitted version of the clean data page. So all of that is what we have to specify to create that navigation bar. So once that's all set up, we just have a bunch of R Markdown files. We have this site.yaml file where we say make a navigation bar. Over here on the build panel, there should be a button that says build website. So if you click on that, what that's now going to do is show a whole bunch of output here. It's going through and knitting every single one of those R Markdown files. So right now it's working on clean data. Scroll down. It's working on the next one and the next one. It finished. And here it is, the website. So now we have an about page. There's the about this data page. We have a data cleaning page. There's our cleaning the data page. We have explore the data. There's our cool pictures. We have model the data. There's our cool regression models with the math and the picture and the table. Everything's in there. And then if you click on conclusion, we have a conclusion. This is really cool. I've had students in some of my classes turn in final projects this way instead of like a giant PDF. They split it up into separate little website pages and they turn in a website. And the really cool thing about this is you can actually add like interactive graphs. This could potentially, like you could hover over this if you use a specific package called Plotly that will convert this into interactive JavaScript. And so that way you can like zoom in on these pictures. You can do all sorts of cool things. It's just a website. And then if you want to share this with people, everything it just created, we'll close this preview. In the files panel, there should be a folder called site_site. If you look in there, that's where all of the rendered HTML things are. So those are the standalone HTML files. That folder, that site folder, that is what you can distribute. You can put that on the internet somewhere, and then somebody can go to the website. You can email that whole folder to somebody, and then they have access to the entire website. And that's how you create the website. Really, it's really just a matter of having a bunch of R Markdown files. It'll knit all of them. And then if you want them to show up in the navigation bar, that's what this site.yaml thing is for. And that's really all you have to do. You don't, so how do you knit the YAML file? You don't. That is just the settings for the whole website itself. So this is where we add, like, if we want to change, this is like Penguin Research. And let's say we don't want the conclusion to be in the navigation bar. I can remove the conclusion part. If I save that, and then I come and build the website, it's going to knit everything. And here's the website. Now the title should say Penguin Research. And there's no conclusion anymore. You can't click on conclusion. It's gone. So that's how you do that. You also have lots of other settings that you can do that's all documented in the documentation here. So like that was kind of a boring looking website. We can make it fancier, add some color. So I think if you go to site configuration, you can scroll down and common elements. That's what we want to look at. So if you notice here, it has other example versions of this site.yaml file. So again, the navigation bar. You can also control the theme of the HTML file. You can change how the code is highlighted. If you want to add your own custom HTML, like if you have some fancy JavaScript thing that you want to add, or if you want a footer to show up at the bottom of every page, you can add all of that. So I'm just going to copy this from the documentation and come to the R Markdown website thing. So after the navbar section, we'll have an output section. Just delete all of that. So we will just tell it to use this Cosmo theme. Wonder what that looks like. Build. So we wait for it to go. And there's the Cosmo theme. Neat. It has this black bar at the top, and the fonts are a little bit different, and cool. So you can make things look differently. It has a list in the documentation here of all of the different themes that you can add. There's like, I think 10 or 15 different ones. You can actually build your own theme if you know HTML and CSS. You don't have to. So yeah, that's basically it. Like, as far as like teaching you how to do this, that's I just taught you how to do it. It's just a bunch of R Markdown files. So really my assignment for you after this is try making a dinky little website. Don't even worry about R. Just make a bunch of R Markdown files and change stuff. You might have, like, again, like, doesn't have to have R at all. If you look at the workshop website for today, the workshop website for today is just like, there's a page for slides. There's a page for Markdown resources. Look, has cool nested menu things. The documentation shows how to do that. It's really, you just change one thing in the YAML file, that site YAML file, and then that lets you create this nested menu stuff. So that's my assignment to you, is just to play around. Recommendations for where to host the website. You cannot put it on Google Sites. Google Sites doesn't let you upload whatever arbitrary files you want. You have to use their system for editing stuff. So if you want to upload it, there are a couple of different places. The easiest is a place called Netlify. This is magical. So if you go to netlify.com, they have a way of hosting websites, but they also have this thing called Netlify Drop, where if you go there, this is what the website looks like. And if you create an account there, once you have an account, all you have to do, see how it says drag and drop your site output folder here? You take that generated _ site website folder, drag it into that spot, and you're done. It's uploaded on their servers, and it gives you a URL that you can share with people. If you have your own URL, like if you've bought a domain name, you can actually point the domain name at this Netlify drop place, and that's all you have to do. There are more programmatic ways of uploading stuff. You can use like the terminal to upload stuff with rsync or other things. But if you're a drag and drop person, this is the absolute easiest way. Is you make a free account at Netlify Drop, generate your website, drag it into here. If you make any changes, it'll generate a new website. When you use RStudio, you click on build website, it builds it, drag that new folder up, and it'll update it. And that's the absolute easiest way to do it, is with this Netlify Drop. If you don't want to do that, you can, again, if you're familiar with Linux, you can make your own Linux server with a Apache web server, and you can upload stuff there. That's more complex. If you're just looking for absolute easiest, Netlify is the way to do it. Cool. So that is website building. The super neat thing about this is, how many HTML tags did we just write? None. You didn't have to write any HTML. You had to write this kind of cryptic site.yaml thing here. But once you get the hang of it, like if you want to add a new menu item, like let's say we want to have it so people can go to Google fairly easily, we just copy and paste, and we can say Google, and then we can come here, and instead of going to conclusion.html, we'll just say go to www.google.com. If I save that and build the website, we should now have a link for Google, because why not? In real life, you'd probably want to link to like your department's website or the state of Georgia's website or something. But look, now we have Google. We can click on that, and I must have typed the URL wrong. All right, so for the last part of today, what we're going to show is how to make another type of website. It's a single page website, kind of like an R Markdown knitted file, like the Penguins thing we were doing. So this is not like a full-on website with lots of subpages or anything. But what we can create is, using the same idea of Markdown, we can create a full dashboard that has like sections of a page dedicated to like a table or a number or a graph, and you can kind of look at the dashboard to look at key performance indicators for your organization or whatever. It can all, like, dashboards, again, we're not going to go into super detail here because every dashboard is unique. It fits whatever your organization needs. So I'll just show different ways of kind of piecing together a dashboard using Markdown. Very, very little code, no HTML code do you have to write, no JavaScript code do you have to write. It's just all through Markdown. So close the R Markdown websites, our Studio Cloud project, because we're done with that one. That was just the standalone website thing. If you go back to the main R Markdown fun website that we've been using that had the penguins in it, use that project. Again, I will stick it in the chat here. So we had been looking at the Recreate Me and the penguins. There's another file in here called Basic Dashboard, which we won't open quite yet. What we're going to do is create a dashboard, a blank dashboard. So if you go to File, New File, New File, R Markdown, it'll bring up this new file dialog thing. I already showed you this when I wanted to get that global echo equals false, echo equals true code, because I can never remember how to type it. You can also, if I click on From Template, I can tell it to make a blank Flex Dashboard document. Flex Dashboard is what we're going to be using for the next few minutes here to create dashboards using just Markdown. Again, no HTML at all. We're just making columns and rows and dashboard elements just with Markdown and some R code. So if I click on Flex Dashboard here and then click on OK, it should give us a blank document that's all set up for working with Flex Dashboard. So again, if you look at the top, there's our metadata in between the 3 dashes, and this thing is called untitled. Neat. Scroll down, here's an R chunk where it's going to load the Flex Dashboard library. Include equals false means that chunk will not show up, so you won't be able to see any R code or that R code in the document. And then if you notice, there's some Markdown here. For whatever reason, so there's another way. So if you want like a second level heading in Markdown, you use 2 pound signs. An alternative way is to do a ton of dashes. I don't know anybody who does that, but you can. That is also a second level heading, but that's kind of annoying. So what I'm actually going to do is delete all those dashes and then put 2 pound signs in front of column, because I like that better. But the way this works, the way this Flex Dashboard thing works is you create columns in the dashboard using 2 pound signs, using a second level heading, and you create rows inside the columns using third level headings. And that is how you create kind of the layout of this dashboard. So just by looking at this, you can see that we have a column with one row in it. Then we have another column, which again, I don't like those dashes, say second level heading. We have another column that will have two rows in it. So we have chart A, and then we have chart B and chart C in a second column. And to see what this looks like, I'm going to click on knit. It's going to want to save it, so I'll just save it as whatever. So when I knit, this is our dashboard. It's empty for now, but you can see the title. That's from the metadata. Here's the first column where chart A could theoretically go here. And here's the second column. Chart B goes here and chart C goes here. And the cool thing about this is like it automatically set up this whole layout without having to do any HTML code. It picked it up from here. Like it knows that that's a column with chart A in it. This is a column with chart B and chart C in it. The reason this chart A column is wider is because you can actually specify widths here. So this is 650 pixels, that's 350 pixels. So this one's going to be wider. If you take that part off, they'll just be equal widths. If we don't want that to say chart A, and instead we can say like annual sales numbers. If I knit this now and look back at it, there is our annual sales numbers row. Okay, so that is basically what we're doing is piecing together a whole layout using columns and rows. The columns are defined using the second level headings. The rows are defined using third level headings. So now if you open up this basic dashboard.rmd file, this is a dashboard that I already made. I'm using the penguins data that we've had before. And again, it follows the same structure. You have this metadata at the beginning. So it's going to be called dashboard fun. It's got some R chunks in it. Echo equals false means none of the code in the whole document will show up. Then we have a column, and then we're going to have a static plot in that column. And then we have another column with some gauges and an interactive plot. So just go ahead and knit that basic dashboard. You don't have to change anything. You just knit it. And it should look something like this. Cool. All right. Mine's zoomed in funny, so the gauges take up tons of room. But we have a picture here that's just there. We have these gauges that I just chose random numbers on a scale of 1 to 10. You could imagine this is like number of applications handled, number of applications in the queue, whatever you want to call these. Like these are just kind of ways of looking at whatever key performance indicators you're looking at. This plot right here is it's an interactive version of this, where you can hover over these dots and it'll show you what penguin it is and what island it lives on and its weight and its height or its build depth. And so this is all just different pieces of the dashboard are just getting all assembled together just like that. So that, again, really the only way to learn this is to just kind of play with it. If you go to the website for the workshop, so if you go to the website for the workshop and go to the R Markdown and Interactivity menu, you can click on Dashboards. And then here I have links to the documentation for Flex Dashboard, which is also very extensive. So if you scroll down, like you can see the table of contents here, it shows you how to basically do what we've been doing with columns and rows. You can do different arrangements. You can have rows with columns within the rows. You can have all sorts of things. And then as you scroll down, it has ways like here's how you make the gauges, like the contact rate and the average rating. And it gives you example code that you can just copy and paste directly in to play with stuff. And you can see all sorts of things. You have these cool value boxes where you can get like little icons in the background. So you can see like the number of spam messages your organization got. Again, this is totally up to you and what your organization needs. But in the end, like this is basically all you're doing is just like using Markdown again to make columns and rows, and then you stick stuff in those rows and columns. So like these gauges, this comes from a function called gauge. So I'm saying it's the number 5, ranges from 1 to 10, and then we have these specific colors. So it's going to be colored as danger if it's between 1 and 3, warning if it's between 4 and 7, success if it's between 8 and 10. Sure, I just made those numbers up. If you don't want one of the gauges, just get rid of it, and we can actually put regular Markdown text, regular text here. That should show up when we knit. So now we should just have 2 gauges with some text. And it should look like, it's going slow because of that interactive plot. It has to load all of the data for that. There we go. So now we have regular text here with 2 gauges. So you might have like a paragraph of explanatory text saying, we care about these 2 key performance indicators because of reasons, and then you can show them there. And then there's a plot that somebody can see, and that's the dashboard. So really, it's just a regular R Markdown file, headings, second level headings for columns, third level headings for rows, and you just piece together whatever you want. It can just be regular text, it can be the fancy gauges, it can be plots, it can be whatever you want, and then you get a standalone website in the end. If you look in your files panel, there's an HTML file here called basic-dashboard.html. Email that to people, put it on the internet somewhere, upload it to Netlify, whatever you want. That is your HTML file that is now a dashboard, which is great. It is a static dashboard, so every time you see it, it's going to be the same. So if you're trying to get like a live version of, like if you can connect to like an internal database that shows like current numbers of applications in the queue or something, you technically have to keep re-knitting this file so it can pick up the most recent data. That gets annoying. But if you look at the documentation for Flex Dashboard, it actually shows a way to connect it to something called Shiny, which is an R thing that runs on a server, and it can load data dynamically so that every time you go to the dashboard, it will pick up the latest data. The documentation for that is there. We don't have time to show it because Shiny is a whole complicated, scary beast. But it is possible to connect this Flex Dashboard thing to more dynamic outputs. So again, let's look at a couple examples. If we go to the Flex Dashboard package page here, not the documentation, but just this first link. And if we scroll down to this examples page, let's click on a few of the examples. So these are all, like here's NBA scoring from 2008. Here's a neat dashboard. It's got a table. It's got this heat map thing, so you can hover over it and see scoring in 2008. Neat. You can look at this one. Here's 4 different plots. You can hover over them. They're all interactive. There's actually like sub pages. So we can see here's the geom point page. We can switch to the geom density page. Neat. So this is just 2 rows, 2 columns. We can click on this one. This has some cool explanatory text on the side. This is more interactive. So we can actually have this drop-down menu and it'll show us, I have no idea what this is, cluster 1. Let's look at cluster 3. Cluster 3 looks like that. Don't know what that is. But if you have schools, you can have, like, you can go look at this elementary school or that elementary school, and you can see specific key performance indicators or plots or data or whatever for specific schools or departments or branches of your organization or whatever. And it's all switchable here. And the neat thing about all these examples is if you click on source code, it will show you there it is. So this is all they're doing. That's just Markdown. In 70 lines of code, they created this whole standalone dashboard website thing, which is like pure magic to me. So my assignment to you after this workshop is done is to play with R Markdown websites, try to make just a simple, dinky little website with some pages on it. And then try to make a dashboard. It doesn't matter what you put on the dashboard. You can have plots, copy from the Penguin stuff, just put text, play around with the different examples that they have at the documentation pages for Flex Dashboard. I have links to all of that from the workshop website here, and just play with it. That's the only way you're going to be able to learn this stuff. You now have a good, strong foundation. You understand what Markdown is. You understand that you can just write in a single file and knit stuff to whatever format you want. You know about Netlify drop. I'll put a link to that on the website as well, so you can remember that. How long will you have access to this workshop website? Indefinitely. It's just here. One thing I do, if you go to my personal website, andrewheist.com, which I'll stick in the chat really quick. If you click on talks, I haven't added this one here yet, I will, but it has links to all of the talks and workshops I give. So like if you came to the GIS with R workshop a month ago, you can click on that link and there's the website that we used for that. And now that you know about this Markdown stuff, you can see that this was just a single knitted file. This was just an R Markdown file that I knit. It has a table of contents. These are different headings, and that was kind of the standalone single HTML file that I stuck up online. Because this one's more complicated, it's a whole website, but yeah, everything's there. You can click on all of these and you should have access to all of this. So any questions you have, I will answer questions. The last couple sections were kind of a whirlwind showing the website and dashboard, but that's in part because there's no good way to teach it other than you play with it. So your responsibility is to play with it. So can you write with LaTeX in R Markdown? Yes, you can. But so like notice how we've been, like our examples here, here's the penguins. Here's our penguin stuff. We've been writing in Markdown. If you really wanted to, for whatever reason, you can say, here's some text, EF, bold, text. That's LaTeX there. So if I knit this thing to PDF, it will show up as bold. If I knit it to HTML, HTML has no clue what that is, so it's going to ignore it and just have here's some bold, but it won't be bold. So you don't you can add LaTeX in there directly, but only if you're knitting to LaTeX. If you're bringing in a table, for instance, from Stata, so Stata lets you do something like there's a command in Stata called outreg or outreg2 that will output a regression table as a LaTeX thing. You can copy and paste that directly into here. Like you can add the LaTeX table there. And then as long as you're just knitting to PDF, you're fine. It'll show up just fine, just with the raw LaTeX in there. If you are knitting to HTML, then it won't work and it will break. You won't get your cool regression table. But there are ways to make the tables directly in R instead of like in Stata. So there's a package called model summary, for instance. That lets you create like these side-by-side regression tables here. And the neat thing about this is this changes depending on your output. So if you're knitting to Word, it'll make a Word table. If you're knitting to LaTeX, it'll make a LaTeX table. If you're knitting to HTML, it'll make an HTML table. And so rather than making the results in Stata, it's stuck as LaTeX forever in that case. If you make the table in R, then it can be whatever you want. If you don't care about being able to knit to HTML and to Word, then fine. You can just bring in the Stata files or the LaTeX files from Stata just fine. It'll work. But there are better ways. So if you're doing regression tables, there's this thing called model summary. If you're doing regular tables, there's a package called cable extra that lets you do fancier tables um, that will knit to Word or to HTML or to PDF. So you can get tables that look like this, but it will also look fancy as a PDF and as Word. So yes, you can mix and match. If you mix and match, you're stuck with whatever format you're mixing. So you can also add raw HTML here. I can say like strong, blah, strong. That will show up as bold when I knit to HTML, but it won't show up as bold in Word or PDF. Are the slides available for download? In theory, I may have typed the file wrong. Let's see. Use download PDF of slides. Cool. I need to upload those PDFs. So I will upload those PDFs. The link, I just haven't put that on my server. I just need to drag it in. So I will do that after we're done with the workshop. And the slides are also, if you click on view slides in new window, it should open up this thing here and you can go through the slides on your own, just like that. An intro to data science workshop. I am not sure. That's a question for Tyler. But yeah, so thank you everybody for coming. This was great. Hopefully you learned some neat things about Markdown. Now you know kind of the secret behind how people write things on the internet. All these New York Times reporters and Washington Post reporters, they're all writing in Markdown. They're not sticking R in there, but they're writing in Markdown, and you can too. So do it.